Good afternoon. I'm Sergei Nierenberg from Rensselaer Polytechnic Institute, and I will be talking about why I think black box AI is not the way of the future. Well, everybody knows these days that NLP has made spectacular advances and they have been widely publicized even in mass media. But what we need to pay attention to is that its deployment in critical applications like healthcare and defense is lagging behind. So, why? So, here is what history teaches us. 10 years ago, IBM's Watson beat the Jeopardy champion. And the very next day, IBM declares already we're exploring ways to apply Watson's skills to the language of healthcare, finance, law, and academia. And Ginny Rometty describes the big bet on healthcare as the next chapter in the company's heritage of tackling grand challenges. She says, our moonshot will be the impact we have on healthcare. I am absolutely positive about it. So IBM invests heavily in promoting Watson in a variety of domains, centrally including healthcare. Major directions include even real-time cancer diagnosis. So scroll forward 5 years, and the news is that the Oncology Expert Advisor Project, a collaboration with MD Anderson Cancer Center in Houston, collapses. Its aim was to create a bedside diagnostic tool that would read patients' electronic health records, volumes of cancer related scientific literature, and then make treatment recommendations. Actually, Watson struggled to decipher doctors' notes and patient histories too. In 2021, we quote from an article from the New York Times by Steve Lohr. Today, Watson stands out as a sovereign example of the pitfalls of technological hype and hubris around AI. At the end of last year, IBM discontinued Watson for genomics and shelved another cancer offering, Watson for oncology. Today, Watson's natural language processing capability, quote, powers IBM's popular Watson assistant, used by businesses to automate customer service inquiries. So, Watson today is promoted as a collection of software tools that streamline and automate tasks such as accounting, payments, technology operations, marketing, and customer service. As one TV ad says, Watson helps companies, quote, automate the little things so they can focus on the next big thing. So, as you can see, the contrast in ambition between 2011 and 2021 seems striking, but it is prudent in the short term. Indeed, the low hanging fruit applications that Watson can support still make a lot of commercial sense. But Watson is not and will never be suitable for critical applications because it is based on natural language processing and not natural language understanding. So, natural question is, are more recent AI NLP systems better suited for critical applications? Well, not really. I don't believe so. And that's because they do not understand language either. So, a very recent report by a panel of prominent AI experts explains neural network language models learn about how words are used in context from sifting through the patterns in naturally occurring text. By stringing together likely sequences of words, several of these models can generate passages of texts that are often indistinguishable from human generated text. They are already supporting applications such as machine translation, text classification, speech recognition, writing aids, and chatbots. So these models themselves do not exhibit deep understanding of the text that they process, fundamentally limiting their utility in many sensitive applications, and that's a core finding. So Gary Marcus and Ernest Davis in MIT Technology Review add, GPT-3 seems to have an impressive ability to produce human-like text, and we don't doubt that it can be used to produce entertaining surrealist fiction, and other commercial applications may emerge as well. But accuracy is not its strong point. If you dig deeper, you discover that something's amiss. Although its output is grammatical and even impressively idiomatic, its comprehension of the world is often seriously off, which means, and here is the crucial part, you can never really trust what it says. And trust is the crux of the matter. Uh, the Wall Street Journal adds, Watson was one of IBM's highest profile initiatives in recent years and the big bet on the growing healthcare sector, though results disappointed in part because physicians were hesitant to adopt artificial intelligence. And we can add because they did not trust AI agents. Why? Because both Watson and the current systems implement black box AI. Black box AI agents do not understand what they are doing, and they cannot explain their decisions in normal human terms. Why? Because black box AI agents manipulate language without understanding what it means and or generate language whose meaning they do not understand. So Marcus and Davis experimented with GPT-3. They gave GPT-3 the following prompt, for instance. You're having a small dinner party. You want to serve dinner in the living room. The dining room table is wider than the doorway. So to get it into the living room, you will have to, and GPT-3 generates the following. Remove the door. You have a table saw, so you cut the door in half and remove the top half. Well, it doesn't make any sense. And Marcus and Davis comment, the natural solutions here would be either to tip the table on its side or to take the legs off the table if they're detachable. Removing the door is sometimes necessary to widen the doorway, but much more rarely, and would hardly be worthwhile for a dinner party. If you do need to remove a door to widen a doorway, you take it off its hinges. Finally, a table saw is not a saw that is used to make room for moving a table. It is a saw built into a work table, and it could not be used to cut a door that is still standing. And Marcus and Davis also conclude, what GPT-3 does is something like a massive act of cutting and pasting, stitching variations on text that it has seen, rather than digging deeply for the concepts that underlie those texts. GPT-3 does not care about getting the right answer to a question you put to it. It's more like an improv actor who never breaks character and has never left home but only read about the world in books. Like such an actor, when it doesn't know something, it must just fake it. You wouldn't trust an improv actor playing a doctor to give you medical advice. By the way, I disagree with a part of this assessment because I think that an improv actor who reads about the world in books will understand about this world much, much more than GPT-3. So one more quote from the 100-year study. Although language models such as GPT-3 are capable of producing significant amounts of text that are difficult to distinguish from human-generated text, these models are still unreliable and often err by producing language that defies human rules, conventions, and common sense. So, okay, we need to look to the future. Will the latest machine learning-based NLP approaches repeat Watson's trajectory with respect to advanced critical applications over the next 10 years? That is, first promise, then generate excitement, then failure to deploy, and then recalibrate to much more modest goals? Alas, I fully believe that this will be the case. Unless, that is, these approaches directly address the issues of trust and explainability by endowing AI agents with a natural language understanding functionality based on stored conceptual knowledge. Well, by the way, don't get me wrong, I'm not at all bashing machine learning based NLP. ML-based NLP is of great help in the early stages of language understanding, speech recognition, tokenization, morphological and syntactic analysis, etc. It makes building NL understanders much, much easier. But there is still a lot to do to resolve issues that machine learning approaches simply cannot address. Sophisticated AI agents must be able to, first, understand the meaning of language input, including the goals and biases of the text producer. Second, integrate this meaning into their internal model of the world, of self, and of others. And third, use that model to make decisions about the goals that they want to pursue and how to communicate in natural language to explain their behavior to humans, and also how to learn in a dialogue with humans or learn by reading. Well, of course, language understanding is a much more difficult task than most people realize. I must add, even specialists in the field often underestimate these complexities. Why? Well, that's because language understanding is not only about language. True understanding requires common sense knowledge about the world and about the agents in this world. Why? Because much of what people express and understand through language is not overtly present in text or dialogue. Think of an iceberg. People make ample use of their knowledge about the world and other agents to resolve ambiguities and fill lacunae and do everything else to extract the intended meaning of language utterances or text. Therefore, a prerequisite for natural language understanding is connecting language with common sense knowledge about the world. No advanced critical application that substitutes stringing together likely sequences of words for understanding on the basis of connections between language and common sense knowledge will win the trust of users. Just to give you just a few of examples about the difficulties. Understanding practically every sentence requires common sense knowledge. So Pete envies Martin because he is very successful. So Pete is not successful, Martin is successful. But if I say Pete envies Martin, although he is very successful, it's Pete who is successful. And so the hearer or the agent understanding language must understand it. When I say I enjoyed the movie, I mean I enjoyed watching the movie. When I say I enjoyed the lunch, it means I enjoyed eating the lunch. If the input is the checkered shirt wants another IPA, it means the person wearing the checkered shirt wants another IPA, and the agent who plays the role of a waiter must understand it. So we address all these and many, many other similarly important phenomena in our work. So we describe this work in great detail in this book, Linguistics for the Age of AI, by Marjorie McShane and myself. And it describes how to develop a natural language understander that relies on common sense world knowledge, how to integrate it into a language endowed intelligent agent, a layer, that can support advanced applications in critical domains such as healthcare. And we also describe some of the proof of concept systems we developed so far. You can get free access to the book on this link at MIT Press. Right. Obviously, I cannot in this brief talk address these issues in any detail. Right. But is the acquisition of all that knowledge that is necessary to support the program of work that I am sketching feasible, I hear you ask? Well, this has been a familiar argument against symbolic language processing for almost 30 years. Symbolic AI would work, but it is unattainable at scale. It is facing an insurmountable knowledge bottleneck. We need alternative AI methods that do not require manual labor. Well, is this indeed the case? In reality, machine learning NLP uses a lot of manual labor, as this diagram from the Economist magazine shows. About 80% of tasks in the diagram, all the bluish and greenish hues, um, describe tasks that require manual acquisition of labor, and the model training, model tuning, and all the algorithmic work takes just about 20% of the time required by ML project tasks last year. And yes, I know that there is a lot of work on unsupervised machine learning, but the jury is still out about how this will be successful at large scale so that manual labor could be eliminated. My point is, with a comparable amount of labor, manual acquisition of knowledge for the type of work that we are talking about would be quite realistic. But wait, we have even a better offer for you. Forget about manual acquisition. What we want to introduce is the idea of learning layers. That is, how about having layers learn elements of language in the world as part of their normal operation? So we are developing lifelong human style learning by layers, bootstrapped by a deep language understander and an initial set of language and world knowledge resources, such as lexicons and an ontological world model. We're inspired by how people do it. Indeed, as you know so well, people engage in this kind of learning throughout their lives, starting at age, what, 3 or maybe even 2. As we communicate in language, we learn, remember, and use ever growing amounts of knowledge about language, the world, ourselves, and others. Just as an aside, the proof of concepts, the proof of concept layers we have built so far also incorporate other perceptual inputs that are used for learning, such as simulated vision and interoception. But we are concentrating on language processing in this talk. So layers imitate the way people learn. They understand the meaning and intent of natural language texts and dialogue utterances. They use the results of language understanding to create new and enhance and/or correct existing repositories of lexical items and their lexicons, concepts and their ontology, exemplars of concepts and their episodic memory for decision making by analogy, and heuristic decision rules to develop skills for fast decision making. There are two learning modes: opportunistic, triggered when necessary during layers routine operation, and deliberate when layers are taught by a human team member or are learning by reading. So what's the current status of work at our lab? Well, we have over the years developed several versions of the on-to-send language understanding, and we are working on the next version as we speak. The current bootstrapping support has as its parts an ontological world model of about 9,000 concepts, which translates to about 165,000 RDF triples, and the semantic lexicon for English with about 30,000 word senses. We have additional knowledge support, but these are the main issues there, or the main content. We also have built proof of concept systems featuring opportunistic and deliberate learning in the areas of clinical medicine, human robotic teams for furniture assembly, and autonomous vehicles teamed with humans in simulated environments. I will give you just a very, very brief intro into the Maryland virtual patient application that we built. It's a proof of concept virtual patient environment for training medical students to diagnose and treat diseases of the esophagus. Virtual patient agents are endowed with a physiology model, a world model, a set of goals, and a personality profile. Each is assigned a particular disease with a particular type of progression. The trainees diagnose and treat the virtual patient over time using simulated lab work and diagnostic procedures, as well as repeated conversations with the patient. Results of treatments accepted by the patient automatically modify the patient's physiology and pathology profile. Virtual patients can perceive their symptoms through interoception, communicate with the human trainees in English, reason and make decisions, for instance, about whether to agree to a proposed treatment for their condition. And they also learn new terms and ontological concepts describing the meanings of those terms while engaging in interactions with the trainees. Okay, so the promise of lifelong human-like learning based on language understanding is the main topic of this brief presentation. So the goal is this: to deploy trustworthy advanced AI applications, we must overcome the knowledge bottleneck through lifelong human-like learning. The most sensible strategy is hybridization. The most promising strategic direction is hybridization, taking advantage of the spectacular successes of machine learning methods to enhance the quality and effectiveness of lifelong human-style learning. And yes, I am fully aware that this line of reasoning is the reverse of how most people today are thinking about hybridization, which is how to use elements of symbolic knowledge to help deep learning applications. Well, but as we have seen, this will not lead ultimately to trustworthy explanatory AI systems. So moving forward, I have only very, very briefly sketched a novel long-term research and development direction of the high-risk, high-yield kind. Many more choices and decisions must be made to concretize a specific viable research and development path toward lifelong human-like learning based on language understanding. Should you be intrigued enough to want to discuss this issue further, let's. Here is my email. Write to me. Finally, I would like to send you off with this slogan: Black box AI is in danger of becoming yesterday's technology of tomorrow. It is in our common interest to avoid another AI winter. In my opinion, working on NL understanding is a promising path to a continued AI summer. Thank you.